A lot of circumstances influence the driver in traffic and thus road safety. For passenger protection, active and passive safety systems are therefore continuously being optimized and adapted. A crash lasts about 250 milliseconds. In this fraction of a second, the airbag control unit has to make a decision. How strong was the impact? Are the crumple zone and seatbelts enough to protect the passengers? Or is it necessary to also activate the airbags and belt tensioners? That's where the airbag control unit comes in. It has to distinguish between different crash scenarios. Was it only a harmless impact? Or a severe crash? Crash severity depends on different factors: vehicle speed and mass, impact direction and angle, and collision point characteristics. Therefore, the different sensors are positioned so that they are able to register accidental changes along the vehicle's longitudinal axis X and transverse axis Y. The airbag control unit is equipped with two sensors. One acceleration sensor that records forces acting on the vehicle's longitudinal axis X, and one that records forces acting on its transverse axis Y, or in parallel. To evaluate accidents even more precisely, the vehicle is also equipped with external crash sensors. The vehicle front can be equipped with acceleration sensors. They measure vehicle deceleration in the longitudinal direction even earlier. Their signal is directly transmitted to the airbag control unit. Even in the case of a side crash, external sensors can help to improve signal evaluation in the airbag control unit. These can be acceleration sensors or pressure sensors in the front doors. Their signals are directly forwarded to the airbag control unit. Only after the evaluation of all sensor signals, the airbag control unit decides whether and when which restraint system is activated. Some vehicle types additionally make use of structure-borne sound to evaluate the crash situation. They make use of the Crash Impact Sound Sensing Technology, or CIS for short. With the CIS technology, the acceleration sensor for the vehicle's longitudinal axis X in the control unit is also able to evaluate how fast and to what an extent the vehicle's body is being deformed when impacting with an obstacle. When the vehicle body is deformed, high-frequency sound waves and thus vibrations are generated. These vibrations are transmitted via the longitudinal members to the airbag control unit and registered by the Crash Impact Sound Sensing Technology. Just like a person who picks up and analyzes noises, the CIS technology categorizes a crash scenario on the basis of sound waves. The airbag control unit uses the resulting data to trigger targeted measures independent of external sensor signals. The CIS sensor's interior is equipped with movable and fixed fingers with an elastic silicon mass in between. In the event of an impact, the sound waves act on the movable fingers and change the electric capacitance between them. The Airbag control unit evaluates these changes and can now control the activation of the airbag and belt tensioner more precisely, dependent on the actual crash situation.